So let's suppose we have a person that pulls on a sled for 10 meters with a horizontal net force, a constant horizontal net force of 30 newtons. Now they then approach an inclined plane with an angle of 30 degrees and pull the sled up for 15 meters. Now once at the top of the inclined plane, the person pulls for 10 more meters with a horizontal force of 20 newtons. So we want to find the net force during our entire trip, knowing the mass of the object is 10 kilograms. The mass of the sled is 10 kilograms. So let's begin by breaking down our problem into 3 sections. So interval number 1, interval number 2, and interval number 3. So we basically want to find the work done on the object during each interval, sum those values up, and that will give us the net work done. So let's begin with part 1, interval 1. So we're moving our sled that has a mass of 10 kilograms 10 meters along our x-axis with a constant net force of 30 newtons. So our displacement direction and force direction point at the same exact direction. So that means we simply take the force and multiply it by our displacement, and we get 300 joules of work. Now what about step 2? So step 2 can be done, or interval 2 can be done in 2 ways. We can either find the net force acting on the object along our inclined plane and multiply it by 15 meters, or we can find our displacement along the y-axis and multiply that by the force acting on the object along our y-axis. So let's find the net force acting on the object along the y-axis and find our vertical displacement and multiply those 2 things out. So we know that our angle is 30 degrees, and we know that our hypotenuse of our inclined plane is 15 meters. So we simply use our sine trigonometric function. So we have 15 times sine of angle 30, which is 15 times 0.5, which is 7.5 meters. So our displacement of the object, the sled, along our y-axis is 7.5 meters. And the only force acting on the object along our y-axis is the force of gravity. So essentially the person is working against gravity and displacing our object a distance of 7.5 meters. So that means we take our mass of the object, our gravitational acceleration, and multiply that by our displacement along our y-axis, and we get 735 joules of work done in part 2 during interval 2. Now in the final interval, we do the same exact thing as we did in the first interval. We simply take our force acting in the same direction as displacement, which is 20 newtons. So we multiply 20 times 10, and that gives us 200 joules of work. So we did 300 joules of work in the first step. We did 735 joules of work in the second step and 200 joules of work in the last step. So we sum up the individual works. We have 300 plus 200, that's 500, plus 735, that gives us 1235 joules of work. So this is how much energy was transferred to move our object from this initial position to this final position.